question 5 of the acids and bases worksheet. So we're taking it from the KwaZulu-Natal paper, also the high grade paper from November 2000. They give you a reaction, and you've got ammonium plus hydroxide gives you ammonia and H2O. Now they say write down the conjugate acids in the above reaction. Okay, we need to be careful here. This is an acid, that's its conjugate base. This is a base, this is its conjugate acid. So actually there's one, and it's the liquid. I know they've said acids. Sometimes, because it's a reversible reaction, alright, what they're saying is if we go reverse the reaction, so if we go that way around, this is a base, this becomes its conjugate. So this is the conjugate for the forward reaction. This is the conjugate for the reverse reaction. Okay? Then they want the bases. Well, we've already said the NH3 is the conjugate base for the forward reaction, which means over here that's acting as an acid. So the OH minus is the conjugate for the reverse reaction. How do I know it's going to go in two directions? Well, that doesn't work. I've got a reversible reaction sign. Okay? Now, 0.5 decimeter cube solution is made up by dissolving 4 grams of sodium hydroxide in water, and we want the pH. Straight away, well, we go pH is the negative log of the H3O plus concentration. I need the H3O plus concentration. I'm working with sodium hydroxide. That means I'm going to be able to find the pH of the OH minus concentration first. How do we do that? Well, I know the mass is 4 grams. I know the volume is half a decimeter cubed. I want the concentration, which is mass, molar mass over volume. So I'm going to need to know the molar mass of sodium hydroxide, which is 12, that's sodiums, plus 16 oxygens, plus 1, 40 grams per mole. Oh, maybe I should write that so you can read it. Hey, how does that sound? Per mole. So, I can substitute in what I know. So I've got 4 grams divided by 40 times 0.5, and that gives me 0.2 moles per decimeter cubed. I've now found the concentration of the NaOH. There is 1 OH per NaOH molecule. That means the concentration of my OH minus ions is going to be equal to my NaOH concentration, because it's a 1-to-1 relationship. Now that I've got that, I can use, and now I'm going to write out a space because I forgot how much there's going to be on this one. I've got the OH minus, right? Now I can use the fact that OH minus times H3O plus must give me 1 times 10 to the, 1 times 10 to the minus 14. I have 0.2 times H3O plus, which gives me 1 times 10 to the minus 14. I divide both sides by 0.2. That gives me 5 times 10 to the minus 14 moles per decimeter cubed. I knew from the start that I'm doing the pH. I put this into my calculator. And we don't forget the minus in the front, otherwise you're going to get a negative answer. And we get 13,33. I'm happy with that. It's sodium hydroxide. Sodium hydroxide is a strong base. So 13,3, it's acceptable. I'm quite okay with that as a value. Next. Then they say 20 centimeters cubed of the above solution, so of the sodium hydroxide, which is 0.2 moles, is neutralized by adding 40 centimeters cubed of dilute sulfuric acid. Calculate the concentration of the dilute sulfuric acid. Now, I am going to run out of space with the way I did this one as well, so I'm going to do it over here. First of all, I need to know how they react together. So I have H2SO4 plus NaOH is going to give me Na2SO4 plus water, but it's got to be balanced. So remember what I said, for every hydrogen there has to be an OH. That means I'm going to have to put a 2 there, and it's going to create 2 waters. I know the concentration of the base, I know the volume of the base we used, I know the volume of the acid. That means I can use Na over Nb, Ca, Va, Cb, Vb. Okay, so this is going to be 2 over 1. Concentration, now if you look back here, we used 40 and 20, so we've got 40 centimeters cubed of the acid. We know this is 0.2. We have 20 centimeters cubed of the base. And when we manipulate it and we turn everything upside down, my acid, I think I've made a mistake here. Let me just quickly look. We used 20, I've got them the wrong, no, don't have them the wrong way around. So when I multiply this out, I'm going to have 2 times 0.2 times 40, times 20 divided by 40, okay, which gives me gives me 0.2. Okay, because it's 2 divided by 2 gives me 0.2 moles per decimeter cubed. If you're someone I teach and you're looking at the memo's wrong on the printed one. I am so sorry. Which means the next question's answer also going to be wrong. Then they said the dilute sulfuric acid in 5.2.2 was prepared by adding 10 centimeters cubed of concentrated acid to 490 centimeters cubed of distilled water. Calculate the concentration of the sulfuric acid solution. That would be the original solution. Okay? C1, V1, C2, V2. My original concentration is what I'm looking for. I had 10 centimeters cubed of it. It became 0.2 and I ended up with 500. So C1 is going to be 0.2 times 500 divided by 10, which means I have 50 times 0.2, and that's going to give me 10 moles per decimeter cubed. Okay, hope that helps.